Hello guys, welcome to your 10th C++ tutorial. Today we are going to be looking at our first exercise, and it's going to be challenging, and as I said, you guys will have to think and write your own algorithms and their problems, so you will have to apply some thinking and mathematics. If you don't have a good mathematics background or a strong mathematics, this will probably be more challenging than you might think. The first question is going to be a bit simple, but you still have to think though. The second question is somehow challenging, but not too. Both of them are not too difficult. You just have to think. You just have to be brought out of your comfort zone, and you think and you come up with a solution to these problems affecting us. So I'm gonna go on by just showing you the first one, but before I do that, if you know you won't be able to follow the video, you can just skip it, go down the description below. There's a link to my GitHub repository where you can find the PowerPoint or the PPT representation of this exercise 1, and you can download it, look at the problem over and over again, read it to your own comfort, and you explain it, or you solve it in your own convenience. So the first question, this is the preamble here. Aaron and Sons, I'm using my names. So Aaron and Sons each created one problem for a hackathon. A reviewer rates the two challenges, awarding points on a scale from 1 to 100 for these, or for 3 categories. Problem, clarity, originality, and difficulty. Okay, so then we define the rating for Aaron's challenge to be the triplet A, which represent or which contains values A0, A1, and A2, and the rating for Samson's challenge to be the triplet AB, B0, B1, and B2. Your task is to find their comparison scores by comparing A0 with B0, A1 with B1, and A2 with B2. So basically what it says is you have to compare each of the elements here with its respective element or opponent in this particular array or container here. So then if A0 is AI, if AI, in the case here, let me say an example. In the case where A0 is greater than B0, Aaron is awarded a point. In the case where A1 is greater than B1, Aaron is awarded a point. And in the case where A2 is greater than B2, Aaron is awarded a point. But if it's vice versa, then that will be Samson will be awarded a point each. Then if any of them, if they are equal, if A0 is equal to B0, none of the persons get awarded any point. So given A and B, can you compare the two challenges and print their respective comparison points? That's the question here. Now your input format is going to be a first line. It's going to take 2 lines. The first line containing 3 space integers A0, A1, and A2. That's the elements of the very first container. And the second one to the same thing. And then you're going to take these in using your C in your console input method, and you use it to collect all these data. Then you use that to solve your problem. Now the constraint, this is what is going to be tested. Your application or your program is going to be tested with these ranges. The range of the value of A is going to be between 1 and 100 inclusive. The same for B, 1 and 100 inclusive. So the test points are going to have numerals that are within this range. And the output format here to print 2 space separated integers denoting the respective comparison scores earned by Aaron and Samson. So this is a sample input here. We take 5, 6, 7, and then the second line is 3, 6, and then 10. Now the sample output here is 1, 1. The reason being that when we compare 5 and 3, we get 5 to be 1. 5 is greater, so we award Aaron 1. Then the second one, 6 and 6, they are equal. Nobody gets a point. Then the next one, 7 and 10, then 10 is greater. So what do? We award the second person a point. But in the case where this was this was higher than 10, then we have 2 here, and then this person has, the second person gets nothing. So this is it for the first question. You will have to solve this on your own, write your program, your algorithm, make sure it works. You'll be able to determine whether it works once you feed in input and try to find out what it tells you. So the next question, which is the kangaroo problem. The kangaroo problem is the second challenge, which would give you guys or put you guys in your thinking stream. So there are two kangaroos on an x-axis ready to jump in the positive direction, that's towards positive infinity. If the first kangaroo starts at location x1 and moves at the rate of v1 meters per jump, the second kangaroo starts at location x2 and moves at the rate of v2 meters per jump. Given the starting locations and movement rates for each kangaroo, can you determine if they will ever land at the same location at the same time? So here we are going to have our velocity and then our location that we start from. So basically the input, it is a single line of force space separated integers denoting respective values of x1, v1, x2 and v2. These are the constraints. The constraints, as we said in the first one, this meaning x1 and x2 are within this range, and then v1 is within this range, v2 is within this range as well. Then we move to our output formats. Yes, the output is there. The input format, yes, the input format is there. So the output format, you print yes if they can land on the same location at the same time, otherwise you print no. Now this is a very important note here. The two kangaroos must land at the same location after making the same number of jumps. Okay, so this is a sample input here, 0, 3, 4, 2, and then the sample output yes. So here the reason is when we take 0 and we hop 3 and we hop another 3, we're adding 3 to our 0. So we take 0 and we hop 3, we hop 3 again, we hop 3 again. Then we finally get to something called 12, or a number called 12. That is after how many hops? 1, 2, 3, 4 hops. Then we take our second one, which is 4 here. We do the difference here is 2, or our velocity or our v or rate is 2. Then we do the hopping, that gives us 6, 8, 10 and 12. Also after 4 jumps, that is what this one says. After making the same number of jumps, after making 4 jumps, these two eventually land on the same position. Thus the kangaroos meet after 4 jumps and we print yes. So this is what you are supposed to do. Print yes if our first kangaroo and our second kangaroo can meet at the same location at after a certain number of jumps. So this is the end of this slide, and these are our problems. Good luck with your solving. We will see the answers or the solutions tomorrow, but take the whole night to solve your own. Try to solve it before we try to see the solutions or my algorithms tomorrow. And your algorithm can be correct. There are many ways of solving these problems. I'm going to show you my way of doing it. But if you are able to solve it and you test it with several inputs and then you realize your algorithm is correct, then don't be alarmed. You are on the right path and you are a programmer. So I'll see you guys in the next tutorial where we look at the solutions. Bye.